Wi-Fi Tech Lab channel. Today's topic will be actually trying to troubleshoot this 3-tier network. As you can see, we have OSPF protocol that we will be actually utilizing on this lab. We have pre-designed this network architecture. Actually, this is 3-tier network. I know that we are actually supposed to be starting from scratch from a small office, home office, go to 2-tier network, which is the collapse core, and then come to 3-tier and further move on to the spine layer 4. Now let's just use this one as the demonstration so that we will try to tie up together all of those protocols that we have pre-configured on the previous lab, and then let's see how it works out. And then also we will dive deeper in the OSPF and see how actually the designated router is elected, and also how the backup designated router is elected on the OSPF, and which one is actually responsible to central control all of the information of the link state advertisement, and then which one also keep the database of the link state. Okay, so without no further wasting of time, let's just start with the left hand side. As you can see, we have multiple VLANs on the left hand side, or if we move along to the right hand side also, we can see that we have multiple VLANs, we have multiple departments. In this case, we have tried to use the class C IP addressing on these departments, and then as you can see, we are using /24. So that means that the usable IP addressing on each of these network IDs, it's actually 255 or 254 IP address, and then 255 is the broadcasting IP address. Okay, now what you see, we have the HR department, and then we have the office on the left hand side, and here we have the library. These are just the names. They really don't mean anything, but it's just an example. And we have printer room in here, and then we have multiple PCs that are connected on the same switch as the printers. As you can see, we have Konica Minolta, we have HP 512 LaserJet, and then we have that Epson printer L1260. If you move to the right hand side furthermore, we have a data mechanism. We have data primary save, and then we have the secondary, and then we have the backup. Is connected to the same switch, and it's using the same network ID of 192.168.5.0/24. If you move further up, we will see that we have a VLAN 60. We have this head office. Okay, I can just change this into a server room, and let me just change this into a server room. Let's say server. Okay, this should be server room. All right, and then on the server room we have multiple servers that provide the service. We have a DHCP server. This actually creates the pool where all of these devices on the network, they will be able to pull the DHCP from. And then we have DNS. These have multiple records that can be used. And then we have FTP. This is a file transfer protocol, which is used to transfer file across the network. And then we have the web. This could be IIS, and then it also could be the Apache server. In this case, this is just for a demonstration. Okay, all of these servers or bare metal servers, they are connected on the same switch. All right, so again, this is a 3-tier network, and then as you all know that this is an enterprise network design that actually focus on creating the scalable, reliable, secure, and efficient infrastructure that meets the business organizational needs. Okay, so what you will notice here, you will find that we have actually the access layers here. These switches, they belong to layer 2 classification, as you can see. And these are close to the end host devices, which makes them the access layer, which provide endpoint to connectivity, such as PCs, phones, printers in this case, as well as servers. Okay, and then we have something called a distribution layer, which aggregates, this is a distribution layer which aggregates the access layer and the core layer. Alright, let's move on to the core layer. Okay, the core layer actually is responsible for high-speed backbone for interconnected distribution layer. Okay, now what are the advantages of this? This is scalable actually. So there is fault tolerant. We have multiple redundancy solution that we have. For instance, this one, if this switch goes down, all of these access switches, they will be able to communicate via the multi-layer switch too. Okay, now let's go back again to check all of the VLANs on this department. So we have VLAN 10 on this department of HR. We have VLAN 20 that use this network ID, which is 192.168.2.0, and then we have library. This one also uses VLAN 30, 192.168.3. You could use any VLAN as long as it's fall within the range of 1 up to 40946. Okay, now let's come to this one. This is VLAN 40. It utilizes 192.168.4.0, and then also on this data center we have VLAN 50. Okay, actually we can just say we can aggregate these two into one, but let's just leave the name as they are for now. Okay, and then we have VLAN 60 on the server room. Okay, now let's move on to the multi-layer switches. We have trunk links that come directly from the layer 2 switches to the multi-layer switch. This is multi-layer switch 1, and then this is multi-layer switch 2. Okay, so we have these trunk links. As you can see, these are the broken lines. They represent the trunk links, which means each and every access layer switch connect directly to the distribution layer switch. Okay, we have one link that goes to this switch, and then we have the second link that goes to the other switch. Same thing applies on this switch. On the layer 2 switch on HR department, we have one trunk link that goes to the multi-layer switch 1, and then we have another trunk link that goes to multi-layer switch 2. Same thing applies to the rest of the VLANs, or to the rest of the multi-layer switches and the layer 2 switches. Now let's move on to the core layer. We have actually these switches. This is the backbone which ensure that the network is actually on its optimum, and then we have this ISP. We have ISP1, and then we have ISP2. As you can see, these ISPs, they are not directly connected to each other. They are just there to offer us the redundancy solution and the failover, just in case if one primary internet goes down, the other one will remain active and forwarding traffic, okay, as it's supposed to the internet. Now let's dive in. Let's start from the layer 2 switches. Let's start from VLAN 10, and then we'll move along and check all of the configuration on all of these layer 2 switches up to VLAN 60. What do we know so far? We know that in order for us to have VLANs, we have to type the command VLAN 10, or in this case I'm just making an example about VLAN 10. We just have to type in the command VLAN 10, and then we create the name. And then, ever since this is the lab that is created to save time, to cut the video short, we have already done that. So all I have to do is to run the command that will allow us to see all of those configuration. I will first enable the switch and then type in the command config terminal. Okay, now that I'm on the global config mode, I can be able to see the configuration that are saved on the switch on an NVRAM. So all I have to do now, I have to try to type the command do show VLANs, because I want to see the VLANs that are created on this switch. In this case, as you can see, we have the default VLAN, and then also we have VLAN 10. Alright, and this VLAN is active, and then also that one is active. So what do I know about all of these interfaces on that switch? So we have these 4 interfaces that are part or associated with this VLAN. Remember, this is just a demonstration purposes. It could be all of these devices belong or fall under this particular VLAN ID 10, then it could be any name that you prefer. This is just for video demonstration purposes. However, this is just a simulation. However, we'll be moving actually on a tool that is called EVNG. That's where we will be actually seeing how this is done on the real environment. Okay, so for now, let's go back to the switch, which is switch 4. As you can see, we have said that there are 4 interfaces that are associated with VLAN 10. If you look closer, we also use all of these interfaces, which is fastener 01, fastener 02, and then we have 3 up to 4, which is a printer that we use. So if I click on this printer, you'll be able to see that it also has some interfaces. So we will come back to the IP. Okay, so basically we have actually confirmed that the VLAN has been created. It was assigned some interfaces, and then there is a name that was given to this VLAN. All right, so let's find out about trunk. Do show IP. Okay, let's see if we're gonna be able to see do show trunk. Let's see if we're gonna be able to see it. If we, okay, let's say do show VLAN trunk. Okay, let's press this one. I'm typing the wrong command. Okay, let's do this again. Do show IP interface trunk. Do show interface trunk. Let's see. Okay, do show interface trunk. This is the interface that we're willing to actually see the information about. This tells me that these are the ports that are associated with the trunk. So as you can see on that switch, we have used these as our trunk links because they will be responsible to encapsulating the .1Q tag. So which means that there will be multiple devices that it's possible that they might be actually having the different traffic, and the traffic will pass through all of these interfaces at once. So this take the trunk as some kind of a channel which can encapsulate or let pass through of the data that belongs to different network IDs at once. So in this case, we have used only one network ID, which is 192.168.1.0/24. Okay, now we have these 2 interfaces. They belong to actually the trunking, because we have configured these interfaces as trunk. Okay, those are the trunks links, and then all of these interfaces, they are access. All right, so let's go to this switch and verify also the configuration. Now if I come to this switch and run the command do show VLAN, I'll be able to see that the interfaces that are associated with this VLAN 20, this is the VLAN ID that is created based on the layer 2 switch. This is the department. We have called it office, just an office, ordinary office, and then we have used these fastener 01 up to 4 as our interfaces that we have chose to associate them with part of VLAN 20, which we have created with the VLAN name office. All right, now what else can we check on this? We can also find out what is the trunk links. We're expecting the trunk links to be the same as the one that we've been using all along here, which is Ethernet fastener 0/6 and 5 and 6. All right, so we need to type in the command do show interface trunk, do show interface trunk, because this is what we're trying to see. As you can see, this encapsulate .1Q tag. All right, and then these are the interfaces that are associated with VLAN. with that VLAN 20. All right, this is a trunk link. All right, so let's go. Okay, let's go to the following department, which is this one. Let's do the same thing. So enable config terminal. So enable config terminal and to show VLAN. So what do you see? As you can see, we have the VLAN ID 30, and then we have the VLAN name, which is library, and then we have those multiple interfaces that we have associated with that VLAN. So the list goes on and on the same way on these multi-layer switches. So it's the same thing applies on printer room and then also on the data center and the server room. Don't mind this data center and the server room. I can use actually any name. Okay, so this is just the name that I chose for demonstrational purposes. Now, what I was saying is the configuration on these switches, they are all the same on these access switches. All we have to do now, we have to check our devices here. Let's verify or validate if the DHCP pool is working accordingly across all of these devices on the network. All right, as you can see, all of this department, they have even though this is not a good practice, but to make you understand that actually we can do this. We can actually do this in all of the departments to ensure that each and every department it have its own network segment to enhance security and also the effectiveness of the packet forwarding. Okay, now let's do this. So we're trying to see if all of these devices, they can obtain the IP addresses from this DHCP server that we have already assigned the pool, and then I'll show you exactly how did we came to assign the pool. So the first thing that we did, we chose to assign the IP address, which is static IP address, on the network interface card of this server. Okay, this is a server, this is a server. As you can see, it looks like it have some multiple disk here. It could be RAID. So, and then we have this interface here. This is the network interface card, and then you will find that there is another slot in here. This is an empty slot. However, we can actually try to get another slot. As you can see, as I'm selecting, it's changing here. We can get another slot, and then we can try to pop it in here and then create something called NIC teaming. So for now, let's just leave that one, and then let's focus on this. So all that I did was to come here on the network interface card settings, and then I have chose to assign this static IP address on that interface on the DHCP server. This is 192.168.6.100, and then this is using the class C subnet. So as you can see, we have this subnet mask of 255.255.255.0, and then if we move along to default gateway, the default gateway that we chose to use in this case, we have used 192.168.6.1. This is the default gateway that we'll be using on the VLAN ID 60. Okay, and then this is the IP address of the DNS server. Okay, that's going to be keeping all of the records. So this is the DNS server. All right, so this is the DNS server's IP address. As you can see, we have configured it as 192.168.6.121. Right, now we have the default gateway of 192.168.6.1. again, this belongs to the same subnet as the DHCP. So this is actually belonging to 255.255.255.0. Okay, so let's move on to the FTP. This is the file transfer protocol. I'm not sure if we've configured this, but I can actually show you how to configure this. Before we move to the file, let's go back to the DHCP and the DNS. So we have spoken about the IP address, but now we have to go and ensure that the services were enabled, and also those pool were actually addressed to the pooling. And then, as you can see, we have created the pools in here by enabling the service, and then we gave it a name. This could be any alias name that makes sense to that department, and then we have specified the default gateway and the DNS. So now let's do this. Let's start by this one. This is HR. As you can see, we have this network ID of 192.168.1.0. so we have chosen to use the default gateway as the first usable IP address on that network ID. In this case, we have used 192.168.1.1. so the DNS server doesn't change. We will be using the same DNS server, which is this one, and then we have the certain pool that we preferred. So in this case, we didn't modify it, but however, I can choose it, or I can modify it according to the way that I preferred. In this case, I just left it as it is, even though it doesn't make sense to start leasing the IP address from .1.0, but I'll leave it as it is so that you will see that the first usable IP address will start from 2, 3 upwards. Okay, now let's go to the office department. As you can see, the same thing applies. We have this network ID of 192.168.2.0. this is the network ID of that VLAN 20, and then we've chose to use 192.168.2.1 as our default gateway. And then the DNS server that we'll be using is the same DNS server that we've been using all along. Okay, now this is the same setting that applies on the HR department. The list goes on and on the same way according to these VLAN IDs. Alright, now let's move on to the DNS server. On the DNS server, we have these services that we have enabled. Okay, actually there is one record that we have created. This is actually 192.168.6.12.6.121, and this is the A record, which means if I can go to any host device from here, I can be able to type in the command nslookup and then type in the IP address. I'll get exactly the domain name that I'll be that we've been configured on that. Okay, on that service. All right, now let's go to the file transfer protocol. Remember, the secure version of this is SFTP. In this case, we have only this one in this demonstration. So we have 2 users here, and then we have username and the password. Right, now let's move on to something called the web server. This could be running an HTML code, cascading style sheet, and maybe some JavaScript, whatsoever the code that you'll be using. In this case, this is just a hello world test HTML code, a simple web code. And then if you try to browse this through the internet on each and every PC on the network, you'll be able to see that you will be actually getting that that code that is on that HTML index file. Okay, now let's go to the multi-layer switch. Okay, let's wait for it a bit. Okay, it looks like it wants to open something. So it didn't open anything. It's fine, we can leave it for now, and then we'll come back to it later on. It looks like the video is gonna be long. It's okay. Let's try to push as much as we can. So basically we have multi-layer switches. We have 2 of them as a result of trying to have a redundancy solution on the network. Okay, so we have these trunk links that are surrounding the interfaces on this multi-layer switch, and then let's just verify all of these. Config terminal, so on this distribution layer, remember this is the layer where the access layer is being connected to the core layer. So basically what we're trying to verify in here, we're trying to see that the inter-VLAN routing configuration is done properly on this layer. How we're going to be able to check that? We will have to see each and every interface VLAN and see which IP address that it got. Okay, let's start by typing the command do show IP interface brief. This will show us exactly the interfaces that are utilized, and then it's also going to show us which IP addresses are assigned on those interfaces. Okay, so above that, do show IP interface brief without this dot. Okay, as you can see, some interfaces, they are actually down, but if you go further down, you'll be able to see that we have VLAN 10, VLAN ID 10, and then we have utilized this default gateway, which is 192.168.1.1, and then the interface data is up. If we go to VLAN 20, same thing applies. We have utilized this 192.168.2.1, and then the interface is actually up, right? Also VLAN 30, VLAN 40, VLAN 50, VLAN 60. If you don't know how to configure this, all you have to do is to type in the command interface VLAN, and then you specify the ID. Okay, the ID could be from 1 up to 4094. Okay, so this is how you actually configure or assign the interface on the VLAN. Now, what about if we actually willing to see which IP helper address that we actually have been using? Let's run the command do show run. This actually will be able to tell us which IP address that we use as our DHCP server. Okay, do show run. Right, let's just go further down and verify this. Okay, let's see if we can verify this. I'm just gonna keep on pressing. Okay, there we are. Now, as you can see, if I go to the interfaces, remember this is the interface VLAN that we have assigned the IP address, and then we also specify that this is going to be our IP help address, which is the IP address of the DHCP server that is configured on this interface. Right. So in order for all of those devices to be able to obtain the IP addresses, this is very important. Otherwise, the devices won't be able to obtain the IP addresses automatically. Okay, that was the configuration that we actually wanted to verify to ensure that all of these devices, they are getting the DHCP. The same thing applies. All of those interface VLAN, they are using the common IP helper address, right, to obtain the IP addresses from the DHCP pool that correspond with their network IDs. Okay, configured on the DHCP pool. All right. Now, let's verify also on this multi-layer switch 2. Same thing applies. I'll just type in the command enable config terminal, and then from here I can further say do show IP interface brief. Remember, this is going to tell me about the IP address that are assigned on this VLAN. Okay, as you can see, we have used the same configuration that we have done on multi-layer switch 1. What does that tell you? It tells you that we are actually willing to make this as the redundancy switch, just in case if one switch goes down, the PCs or the client computers or the client devices connected on the end host or access side, they will be able to still receive the IP address pool from the DHCP server. Alright, so that they will be able to communicate each other. Alright, so this is a redundancy solution. And then let's go to something called IP help again on this one by typing the command do show run. Now let's press it down. Okay, as you can see, we have the same IP helper which points the IP address to the DHCP. Alright, so let's verify now if all of these devices they're getting the IP addresses accordingly. So we're expecting that the devices on HR side, they must be getting the IP address that is 192.168.1.2.3 up to 254. Depends on the IP address that I'm using that are connected to that switch. In this case, let's start by the printer 0. As you can see, when I'm clicking, this is the DHCP that was obtained from the pool on the DHCP server. Right, it says 192.168.1.1 is the default gateway. And then actually if I come to the okay, let's do this. This is the default gateway, and then this is the DNS server. Wait, where is the IP address of the interface itself? Okay, let's come in here. Oh, this is the interface then. So the interface of that printer is actually 1.4. Alright, so if we go to this PC, we will be able to see the same thing. If I come here, as you can see, this is not on static and this is on the DHCP. So it means that this is the IP address that was obtained from the DHCP server. The list goes on and on and on to each and every devices. So even if I were to join another PC somewhere on the network, let's do this. That PC won't be able to get to the DHCP. The reason why it won't be able to get the DHCP, it's because on our range, when we're specifying on layer, when we're specifying on layer 2 switch, we have specified the range which says fastnet 01 up to 04, which means now this belongs to another domain, right? This is a separate domain, and then this one is just a separate domain, which means now if in order for us to ensure that this PC gets the DHCP, we must associate it with that VLAN, which is VLAN 10. In this case, let me just do that. So I will try to associate this with that VLAN, which is VLAN 10. Okay, let me just press this. All I have to do to associate is I must select the VLAN, which is VLAN 10, and then I can just say switch port, or let me just say I will just select the interface itself, which is interfaced. Let me verify this. This is actually 7. So this is 7. I don't need to specify the range. I can just select the interface itself. I will have to say interface fast0/7, and then I'll just say switch port mode, or I can just say switch port access VLAN 10. Right, no shutdown. I know the interface is already up, but now let's see what's gonna happen if we try to let's wait a bit, and then we will try again to request for a DHCP pool. Let's give it some time until this turns green. Okay, let's give it some time. Let's give it some time. Okay, maybe I'll have to come back to it once it turns green. Let me see if it's gonna be able to give me that DHCP. Okay, let's just wait for it, and then I will come back to it. Okay, so we will see actually that interface will be able to get the DHCP because now we have associated this interface with this broadcasting domain, which is a VLAN 10. Okay, so let's see, let's verify if it was actually successfully added to the VLAN domain. Okay, now let's find out. Now it has turned green. Now let's find out again. So if I come here and select the DHCP, I'm expecting to get the DHCP pool from the server. All right, let's see what's gonna happen. As you can see, the PC got 1.6. It got 192.168.1.6 because we have chose to associate that PC now with that interface. This is an advantage of using something called the mini switch, so that no one can just plug in the cable anyhow in any port. So you can just ensure that your ports, they are on they are segmented, then the network is segmented, and then also the switch, you have created and associated some multiple interfaces with a particular VLAN. Okay, so that if somebody tries to plug in the cable, they won't just get the DHCP anyhow. So this also avoided DHCP spoofing. Okay, now let's come in here. Let's come to this router here. Okay, the reason why I'm coming to this router is because all of these devices, if I can select any device randomly, you'll be able to see that they actually have the IP addresses that they are receiving from the DHCP server. So if I can come here, you'll be able to see the same thing applies on all of those devices because there is a pool that exists on this DHCP server. All right, we can give it some time. Let's wait a second, and then we'll be able to see that actually all of those devices, they are connected. Okay, let's see, let's find out why that device is actually getting the APIPA. Let's run this again, and then let's see. Okay, it's actually one of those. There are a few interfaces that are added actually, so they are not associated, or they not belonging to. They doesn't belong to that VLAN. Let's see the VLAN ID. They don't belong to VLAN 40. So if I come here, I won't be able to see all of these interfaces as the interfaces that are associated with VLAN 40. However, I can utilize those interfaces that I'll find them being associated with that VLAN. So I'll type in the command enable config T, and then I will type in the command do show VLAN. This will tell me the information about the VLANs that are created on this switch, and you will see that that interface was actually not part of VLAN 40, which is a printer room. So these were only interfaces that are associated with that, unless if I try to adjust this configuration and add some of the interfaces that still belong to the native VLAN, which is VLAN 1. This is a default VLAN, and then if I associate that interface with this VLAN which we have manually or created, then we can be able to request for a DHCP server. Same thing that was applying on here, it applies here. So we're looking for fastnet 01 or 4. This one could be actually a device that can be able to obtain the IP address on this 192.168.4.0 network. So if I come here, I'll be able to see that if I request for a DHCP server, this device must get the IP address. Okay, this is useful for troubleshooting purposes. Exactly, as you can see, we have got 192.168.4.7. all right, and then we have this DNS server that we're using, and then we have 192.168.4.1. so if I actually come in here and type in ns lookup 192.168.6.121, let's see if we will be able to see something like that. Let's find out again where we went wrong. Okay, let's go to the physical interface. Let me remove this. 6121. Okay, we will come back to this and then try to activate it, and then because the reason why it is failing to ping that DNS, remember we did this the same lab on a previous video where we actually have all of these devices communicating on their broadcasting domain. However, when they try to communicate to external broadcasting domain, there is actually a huge issue. In that case, we had to feature something called the routing protocol, and then because of the interfaces were too much and there were too many, we couldn't be able to assign the static routing protocol to each and every interface and specify those network ID that we're willing to connect to and use the number of hops, because on this network topology, as you can see, we have multiple number of hops that we can actually utilize to try and get to the specific network ID. So in this case, to use a static IP address is very not advisable. We will be using something called dynamic routing, preferably for now, because we will be touching based on the OSPF again. So the reason why I couldn't be able to run an NS lookup was because there is no routing protocol that is actually associated with this network topology or this network architecture. All right, so this is a GT again, and then let's just dive into the OSPF. All right, this is the dynamic routing protocol again. So what do we know about the OSPF? The OSPF it's actually a link state protocol, which means it uses the link state advertisement to gather and distribute the information about the neighbor adjacency and the routing information. So basically we have something called the designated router, which is a central point which actually send the information to each and every router. Each and every router that participates on an OSPF, it actually doesn't send the routing information towards each other. For instance, if this is an OSPF area, the router that is in here, if it's not a designated router or if it's not a backup designated router, it won't be able to send the information to this router. However, it will send the information directly to the designated router. And then we have a backup designated router. The backup designated router is the router that share the same information as the designated router, just in case if the designated router goes down, the backup designated router will be able to perform the role of the designated router, right? So it will be sending those link state advertisement and to each and every router. Okay, and then we have hello packets that are being sent to each and every interface. Those are the broadcasting packets. So it's hello packets. They are 10 seconds, and then we have 40 seconds for the dead time. So if there is no reply within if there is no reply within 40 seconds, and then the OSPF assume that the interface is actually down. All right, and then there will be no adjacence between the routers. So there is also something that we will be talking about. It's called BFD in future, bidirectional forwarding detection. It's also works the same as the dead timers or the hello packets. It's actually detect the link before it fails, but in a very, 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 very effective and fast way. Right, so it can actually help to detect the failure before it actually happens. All right, or it becomes noticed on the network. It's called BFD. Let's just focus on the OSPF for now. Remember, what do we need to know about the OSPF? We need to know that amongst the interfaces, we have the bandwidth, and then we have the cost. Okay, so the OSPF calculated the cost towards that destination and see which is the less cost to that destination. Suppose the cost from this interface, let's say from multi-layer, I will just include this multi-layer switch 1 and multi-layer switch 2 as part of the routing devices, and then I will also include it as part of the backbone. Suppose that this is the device that participates on an OSPF, so which means now if we have this device, multi-layer switch, trying to send a packet across to that, for instance, let's say it is trying to send the packet across to, let's say, we make an example. Let's say this is a router. Let's call it an ISP2, right? So let's say there are two parts for now. I will just make a cross, or I'll just do this to indicate the routes that we actually try to demonstrate with, and then I'll just, okay, so let's say this is okay. I hope you see what I'm trying to do. All right, so and then the other, I'll try to select this. Let's suppose maybe the other router or the other route. So let's say maybe the other route is just to come from here and then go over there and then come over here. Okay, and then remember, like just as I mentioned this, that the cost determines which route can be taken to forward the packet. So let's say the route to that ISP is actually, let's say the cost is just 10. I'm just saying, let's say the cost is 10 and the cost is actually 10, and then the cost is just 10. So the cost of the total distance is actually 30. All right, and then suppose here the cost is 20, and then the cost is somewhere here is 30, and then the cost somewhere here is let's say it's incrementing each and every hop. So let's say we have a cost of 10, this is 30 now, this is 60 now, and then for the last time it's 100 all in all. Obviously, because the cost is actually higher compared to the other path. The route that will be taken actually by the OSPF is the route that have the least cost towards the destination. All right, and also there is bandwidth. Okay, so this is 10 to the power of 8. So in this case, the higher the bandwidth on an interface, that is the higher chances of that part to be taken, okay, by the packet. I hope this is informative. So now let's dive in also to try and configure the OSPF. Let's start by these routers over here. These are the OSPF routers. As you can see, they are not directly connected towards each other. What I can tell you for now is that these routers already have the IP addresses assigned onto them, so we don't need to start again, try to assign the IP addresses onto them. However, we'll have to verify and see which IP addresses they are currently assigned on them. Okay, so let's wait a bit. Okay, let's give it some time. Let me move on to the other one, and then I'll have to come back to this one. So these are all configuration of the IP addresses, as you can see, and we actually, I have to change this. This is 100, and then the DNS we have used 121. Okay, so I will have to verify each and every IP address on these interfaces. There is another protocol that we use. It's called CDP, which helps us to detect the interface or the router on the other side of the interface. Okay, now I'm trying to, okay, this is actually taking longer. Okay, now let's enable this router here. This is ISP1 config terminal. What do we know? All we know about the dynamic routing protocol, before we actually perform the routing or before we configure the routing, all we have to do is to enable that routing protocol and give it an instance. In this case, all I have to do is to type in router OSPF. Now the router is aware that I'm running the OSPF instance on this router, and then I'll just press 10. Now if I press the question mark, this will tell me exactly the operation that I can actually perform on this instance. Alright, so I can configure the area, I can specify the area. In this case, remember on an OSPF, the backbone area is the most important area. So without the backbone, the areas won't be able to communicate, and also the OSPF is impossible to occur. So now we have auto cost. We can manually actually configure the cost on an OSPF by typing the command IP OSPF cost, and then specify the cost that we're willing to configure on that interface. And then we have default information. This is actually used when you're trying to originate or you trying to allow the default route to actually distribute the traffic with the OSPF or with any other routing protocol. Okay, so which means I can just type in the command. I can access the routing OSPF instance, and then type in the command router information originate. Okay, and then let's come into the distance and all of those log adjacency changes, neighbor and network. But what we'll be focusing on, we need to make sure that the router ID is configured on an OSPF, and then also those network IDs that we're willing to advertise on the network. However, we have to keep in mind also that if by any chance we forget to configure the router ID, The OSPF, what it will do is it will take one of the interface or one of the IP address that is used on the interfaces by force. So it is important, and especially if you're not sure if you will be using the router ID, at least you must configure something called the loopback interface. How do we configure the loopback interface? The loopback interface is actually a visual interface. It's actually a logical interface that we normally use when we're trying to troubleshoot and to do some routing test. So in this case, we can enable that interface by tapping the command interface loopback, and then you give it an instance, or maybe you can just give it an ID of 1. You can just say loopback interface 0 or 2 or 3 whatsoever, and then you can assign the IP address on that interface. Just in case if you forget to configure the router ID, then the OSPF will be using the IP address of the loopback interface. Okay, now let's configure our routing ID. In this case, I'll start by using the router ID of 1.1.1.1.1. okay, so all I have to do now, I have to come in here and specify router dash ID, and then give that ID. Now that I've assigned the router ID, I need to actually specify the network ID that is actually on this router, okay, where I'm actually configuring the OSPF on. So I know that for sure the network ID of this interface is 10.10.10.0, and the network ID of that is 40.40.40.0, but I need to verify because I have to be sure that the interface is actually running those network IDs. Okay, now let's do that. Let's firstly verify by typing the command do show IP interface brief. This will tell me that there are 2 network IDs that are here, and then these are the IP addresses that are assigned on these interfaces, which is serial 2/0 and serial 3/0. So this is the all information that I needed. However, I also need to know what is the subnet mask that is used on these interfaces. Serial 2/0. Okay, I wanted to actually say do show interface serial. As you can see that we have actually used this subnet. We have used 10.10.10.1.30. This is actually allow only 2 usable IP addresses. Well, this is the same thing applies on this interface as well, as much as the other interface too. So if you pay attention on this /30, this tells us that this network actually belongs to 255.255.255.252 subnet mask. This is the network ID 40.40.40.0, and then this is the first usable IP address. As you can see, this is 1, and then we're expecting that the last usable IP address of this network ID is actually 40.40.40.2. Okay, let's move on to the OSPF. Remember, we have actually assigned the router ID, and also we have to specify the network ID that we willing to advertise, and then on this router. Okay, so we know that the directly connected interface on this router, the first interface, which is this one, it have the network ID of 10.10.10.0, and this is the subnet mask that is used, which is 255.255.255.252. So as you can see, what we used in here, we used 10.10.10.10.0 to advertise this network on the OSPF area 0, and then we specify this wildcard mask of 0.0.0.3. If you don't know how this came about, just know that we have subtracted 255 on each and every octet on this 32-bit network. Okay, so we have actually advertised this other interface as well, which is this one. Okay, now let's move on. Let's just save this. Just move this a bit. Do right. So we're gonna do the same thing on the other interfaces too. All I have to do now, I have to go to this interface, and then I will have to enable this router. Okay, let me just do this. I have to enable this router by typing the command enable. This is the privilege mode, so I have to go to the global config mode, config terminal, so router OSPF 10. Okay, now I have to configure the router ID again. So like I said, there is a point where you will have the router that is elected as a designated router, and then there will be a point where there is a backup designated router, and you must know that in order for the designated router to be elected, there are some other things that to be checked, which is the priority. So the lowest priority, it's actually win between the routers that are connected to each other on an OSPF. So the one that is elected is designated routers, the one that have the lowest priority. If two routers share the same IP OSPF priority, let's say both of them they have a priority of 1, and then there will have to be a check also of the router ID. So the highest router ID will be the one that is used when the two routers sharing the same priority. Okay, so that router will be elected as the designated router. So now we have to configure the router ID again, which is router ID, and then I have to specify, let me just give it a 2. Okay, and then let's do the same thing, which is network. We know that the interfaces that are connected or directly connected to this router, it's this interface, which is 10.10.10.0 network ID. And then all I have to do is to actually give that wildcast mask, and then we have to specify that this router is part of backbone, which is area 0. Right. So if I press enter and wait a second, you will see that there will be adjacency forming between these two routers. Okay, let's do that now, and then let's wait a bit so that you'll be able to see that these two routers will form an adjacency. As you can see, this is actually the status that tells us that these two routers are now neighbors. Okay, so if I can run a command to show IP OSPF neighbor, I'll be able to see that router is the neighbor of the current router that I'm running the command to. Okay, so as you can see that this is actually what is showing that this is the interface, which is this one. This is the interface. Now let's go back to this interface and find out this one, which is 30.30.30.0, and find out do show interface. We are willing to find out the subnet mask of that, even though we know that this belongs to 30. So we need to ensure that actually, let's see, serial 3/0. As you can see, this actually the second usable or the last usable IP address on this network ID of 30.30.30.0, and then this is actually what tells us that the subnet mask of this network ID or the subnet mask of this IP address is actually 255.255.255.255.252. Right. So we would be using the same wildcard mask when we're trying to advertise the network ID on that router OSPF. So let's do this. Let's say network. Let's just say network 30 dot, say to 30.30.0 0.0.0.3 area 0. Okay. Let's say do right, because we have already advertised the other network ID. Now I need to actually be careful in here. Why? Because this interface from here, from this router to multi-layer switch, so basically there must be a network ID that we're using on this interface, regardless of whatever IP that is actually might be configured in here. We just need to find it. Actually, let's see if we can find the IP address that is assigned on this interface. I think it's fast03 if I'm not mistaken, but let's check. Let's double check. I need to come here and then run the command do show IP interface brief. Interface brief. I'm expecting this interface to be the only interface that have the IP address except from the interface VLAN. Okay, so we already know that the interface VLANs, they have assigned with their IP addresses, but I need that interface. I need to see if it's actually assigned. Okay, so this is the interface that is assigned with an IP address. So it's actually FA02, which is using that IP address, and then FA01, which is actually interface. Okay, let's have this IP 10.10.0. okay, .2. Okay, let's do this. So let's exit. Let me just move this a bit so that you'll see. So let's run the command interface do show interface FA0/1. Okay, fastnet is actually up, is directly connected, and then let's see what I'm looking for is actually the IP address on this. Okay, let me run another command do show run config. Let's see on FA01. As you can see, this is actually the IP address that is assigned, and this is a class B IP address. As we can see, there's only 16 bits on the network portion, on the host portion side. So let's just, so it's actually 16 on the network portion side and also on the host portion side. So let's see if we can actually change this, because we don't really need so much IP addresses. We just need to make it to be /30 to allow only 2 IP addresses, not to use all of these so many IP addresses. Okay, so let's do this. All we have to do now, we have to select the interface, which is fast01, and then we need to say no IP add 10.0.0.2. let's say .2 with that subnet mask of 255.0.0. okay, now we need to give it an IP address of maybe, let's maybe say 50 50.50.50 .0. Okay, let's just make it 50.50.0 255.255.252. Okay, it's saying that IP address is actually bad mask for IP address 50.50.50. It's because I'm using actually the network ID instead of the usable IP address on the network ID. So in this case, I actually need to change this into an IP address. So I must come in here and then go here and just replace this and make it the first usable IP address of 1. No shutdown. I already know that the interface is up. Now let's go back to the other interface, which is on this router. I will do the same thing actually. I will just select the interface of interface FA0/0 and then I'll say no IP 10.0.0.1 This is a class B IP address, the 255.0.0, and then let's see what happened here. No IP add. Okay, I need to change this into no IP add, no IP address. Okay, now we have changed this. All we have to do is to actually assign the new IP address, IP add 50.50.50.2 255.255.252. No shut. We already know that the interface is up, but to be make sure. So now we have actually altered or changed this IP address on that particular interface. All right. Now what about this other interface? Okay, to ensure that this is actually the right link between the multi-layer switch and that router, we need to run the command do show to discover actually the device on the other end using the CDP protocol. So basically we need to type the command do show CDP neighbors. This is going to tell us the neighbor that is discovered. Okay, we have discovered this particular neighbor of multi-layer 1. We need multi-layer 1 actually. So this is the information about the multi-layer 1. So we know that this is the interface of fastnet 0/0. This is the local interface, so it's on the router. And then let's see, this is actually connected to fast 0/1, and on fast 0/1 we already know that this is the IP address that we have configured on this multi-layer switch. Remember, we are running a command do show CDP neighbors, and then this tells us the information of the devices on the other end of the cable, and then we can be able to see that this is the multi-layer switch that we have discovered by the discovery protocol. And then we actually found the interface of the same link that we actually connected to. Okay, from fast 0/0. All right, now let's check this fast 02. Let's check fast 02 from this interface. What do we know about fast 02? Let's find out. Do show interface brief. Do show IP interface brief. Okay, so we will see now that this has been changed, and then we are left with this one, which is actually used between this router and this multi-layer switch. Okay, so all we have to do now, we have to dive into this fast 02 and then change it. Okay, let's do that now. First thing first, we need to select the interface, which is FA02. We already know the IP address that is configured on it, which is let me do this, IP add, it's actually 10.0.0. Let me do this, it's 30.30.0.1, 255.255.2.0.0. and then let's run the command again, do show IP interface brief. As you can see now, that IP address is completely removed, so we need to give a new IP address now that's gonna make sense to our network lab. In this case, we're willing to assign the IP address of 50.50.50.5. remember now, this is first usable IP address on the network of .4. okay, because this is the network ID, and then this is the first usable IP address on that network segment. So let's just use this and then continue to use the subnet mask .252. no shutdown, do write. Okay, now we have successfully configured this interface and that interface too. All we have to do is to advertise those two interfaces to the OSPF router OSPF instance 10. Now let's specify our network ID, or let's configure the router ID. So what happens when we don't configure the router ID? You will actually see that the OSPF will elect the highest IP address on that interfaces, and it assign on those interfaces. Same thing that applies in here. If you pay attention, enable config terminal, do show, let's say do show IP OSPF neighbor. Let's see, this is the neighbor that we have discovered. But if I can go to this router and run the command, you will be able to see that the IP address that was taken actually here, it's not the router ID, but it is the IP address that we used on one of those interfaces. Let's find out. Do show interface, do show IP OSPF neighbors. Okay, as you can see, this is actually the neighbor. This is the router ID of the neighbor. This is the one that was used somewhere on this interface, which is serial 3/0. okay, so we need to go back in there, and then we need to specify the router ID on that interface. Right, when things doesn't work, we will have to go back there and then update the router ID so that this interface will be used by this interface. Okay, this IP address will be used by this interface. I hope that is actually makes sense. Now let's come back to here and then specify the router ID. The router ID that we're willing to use in here on this router is actually 3.3.3.3. okay, now let's go in here and say these are the network IDs that we're willing to associate with this area, which is a backbone. So the first one is actually the directly connected interface, which is this one. So if you wanted to also put the that loopback interface, if it was created, you can also put that logical interface. For now, we're just using those directly connected interface. So basically, let's do this. Let's advertise that 50.50.50.0 with that area 0, and then we also know that the other network ID is 4. Okay, so this is the network ID that we have advertised, and then this is the network ID that we have advertised. So maybe let me just do this to make it more simpler. I'll just say 50.50.50.0, and then I'll come here and say 50.50.50.4 to make it more clearly visible for you. Now let's do this again. Okay, maybe let's give some color as well so that we will be able to specify or to be able to point that these are actually the IP addresses. Now let's do this. Let's do this. Let's do this. And let's go up there and do the same thing. All right. Okay, so we were just here. So we were advertising these network IDs. So far we have advertised 2. But what about these interface VLAN? If we don't advertise all of these interfaces here, then there will be a problem, because now those interfaces still they won't be able to communicate each other. So which means if I leave everything as it is right now on the current state, all of these VLANs or all of those interface VLANs, they won't be able to communicate each other. Okay, they won't be able to communicate each other. So this is actually the layer where we can control the traffic and decide which VLAN is allowed to access which VLAN, and also which VLAN must actually go straight to the internet, all right, using the static routing protocol. So you can imagine now, if we were to use the static IP addresses, the static routing protocol, we were to be actually manually configuring all of those entries one by one for each and every VLAN. Okay, so if there is a changes in the network, we will have to actually look where exactly the problem went wrong, and then we will have to find that device, and then we would need to actually manually type those IP routing and then specify the next hop. Okay, so for now we just need to include these interface VLANs in this. So we need to say network 192.168.1.0. we know that this belongs to class C IP address, so it's gonna be like this. Remember, because we're minusing, we're subtracting 255 to the network ID. So if we subtract 255, if we subtract nothing from 255, we would be left with 255. So let's do this now. Area 0. I'm just gonna repeat the same thing and then change the third octet, because everything remained the same except the third octet. Okay. Okay, let's do this. Let's change this into 4. Let's change this into 5. Let's change this into 6. Sorry, let's change that into 6. Okay. Do right. So we have successfully configured the OSPF and advertised all of those VLANs in this multi-layer switch. All we have to do now, we have to go to this side as well and do the same thing. So if I come here, the first thing I need to know, I need to find out what IP addresses are assigned on those interfaces. Let's find out by typing the command do show IP interface brief. So what I'm expecting to see is those old IP addresses that we actually need to remove. Let's start by removing from this interface, which is fast 01. All we have to do is to select the interface fast 01, and then I have to say no IP at 10.0.0.2.255.255.255. It's actually class B IP address, so it's 255.255.0.0. okay, so it's actually 20, not 10. So I have to come here and then change this into 20. This is the IP address that was assigned on that interface that we're trying to remove. Now if I run the command do show IP interface brief, I'll be able to see that that interface is actually gone. That IP address on that interface is actually gone. Now let's give the IP address that correspond actually. Let's first run the discovery protocol so that we'll see that this is actually the interface that we do show CDP neighbor. This protocol is actually a Cisco proprietary. We can use a link layer discovery protocol on other vendors to actually find the status of the other devices on the network. So we're using a CDP here. So let's say we're willing to check whatever is on multi-layer switch 2, not 1 in this case. So this tells us that this is the interface, and then that is actually the interface as well. So whatever is on that interface, whatever IP is on that interface, we need, let's find out which IP address on this interface. Do show interface, or let me say do show IP interface brief. Do show IP interface brief. Okay, what do I know about fast 1/0? This is the interface. It actually have 20 on it. That is the interface, or this is actually the different interface. So this one have 20 on it. We need to actually change this from that router interface. So we need to say IP let's just say interface fast 0 or fast 1/0 IP at, or let me just say IP at 20.0.0.1 255.255.255. Actually I don't even know what is the subnet mask that is used in here, so I'll need to find it by typing the command do show IP interface, or do show interface FA10. Okay, this tells me that this is actually class B IP address. So all I have to do now, actually have to come here and then select that interface again, and then say no IP at no IP at 20.0.0. Let's check again. 255.1, 255.255.0.0, and then let's give our own IP address. Let's see which one we can use in this case. What if we were to use 50.50.50.8 network ID, and then the first usable IP address would be 50.50.9, and then we just say 255.255.255.252. The interface is already up, but we must normalize to type in the command no shutdown. Okay, now let's go to that interface, which is fast01, and we actually know that the IP address would be 50.50.50.10. so all we have to do now is just type in the command IP at 50.50.50.10 255.255.255 dot 252. Now no shutdown. Okay, so again we need to remove this IP address, which is 40.0.0.2 on this interface, and then we will have to give our own. In this case, I'm just gonna do it now right here. I'll just say interface FA02, which is this interface, 40.0.0.2. I will have to remove that by typing the command no IP at 40.0.0.0.2 255.255.0.0. because this IP address belongs to class B, we need to specify the subnet mask that belongs to class B. Now we can assign our own IP address of 50.50.50. Because this is another interface, we will actually need to give another network ID. We can actually give the IP address that belongs to this subnet, and then we will be using 13 as our first usable IP address, and then we will have to give 255, allowing only 2 IP addresses. All right, or maybe what we should have done, we should have used maybe a /28 to only allow 4 IP addresses that we can use between these interfaces. Okay, but it's okay, we can just use these two per link. Now let's run the command no shutdown. We have successfully configured that switch. Let's see now. All we have to do is to run the command router OSPF 10, and all we have to do is to advertise those instances. Remember to not forget to configure the router ID. Let's make this to be the highest router ID, and then let's say no. Okay, network, sorry, let's make this to be network this is the longest video, so let's make it network and include those interfaces 50.50.50.8. This is the network ID where this first usable IP address falls under, so we're expecting this to be 255.255.252. However, we know that we're supposed to be using the wildcard mask, so in this case I'll be saying this is actually 0.0.0.0, sorry, .3 area 0. Okay, now if we advertise another network, the other network is actually 12.12, and then the first usable IP address from this network is actually 13, and then the last usable IP address is .14. .15 would be the broadcasting IP address, and then the following subnet will start from 16. That is the network ID of another network as well. So let's press enter here and then do right. Now let's advertise these interface VLANs. We already know it's network 192.168.1.0.0.0.255 area 0. I can just change the third octet as I've been doing on the other switch. Okay. Remember, we've said that this is the redundancy switch. However, there is a redundancy protocol that we'll be talking about in upcoming videos, where we'll introduce something called HSRP. Okay, so let's say three. Let's change this into 4, and then let's change the other one to 5 and 6. So the other protocol is called host standby redundancy protocol. It's actually used when we want to actually configure the redundancy between the routers. Okay, so that if one stop forwarding traffic, the other one will be able to continue sending the traffic across the network. Okay, so let's say do right. We have actually successfully configured the routing protocol of OSPF 10 on that multi-layer switch 2. All we have to do now, we have to actually come to this router here and actually do the same thing, and we will have to go back to that interface, then advertise those IP address of these two links, which is 50.50.50.5. and let's come here. Actually, let's do it right away. Let's come here and then do show IP interface brief. So this is 50.50.2. now if I come here, do show IP interface brief, we have 50 that one 50.10, and then the other one is actually 50.13. the interface is that one over there, and then the other interface is that one over there. So we have .9, and then we have .10, and then we have .13. So fast 01 is toward that side, and fast 02 is toward up there. So this is 13. So we're expecting that the other network should be the other IP address on this interface should be 14. Okay, so let's come here now and do the same thing, same configuration. All we have to do now, we have to enable the router and then navigate to config mode, config T, do show IP interface brief. Let's see the current existing IP addresses configured in here. So what do you see right now? We have that one and that one. These are the interfaces, or these are the IP addresses we're trying to actually eliminate. We're trying to take out all of these IP addresses and use only two usable IP address on the network. Okay, so what we do now, let's find out do show IP interface, or let's say do show interface FA0/0. This is gonna show me the So this shows me that this actually belongs to class B IP address, which is what we're willing to alter in this case, in this scenario. So let's change this. Let's dive in and change this thing. All we have to do is we need to say interface FA 0/ let's find out. It's actually 0/0. No IP at, we're just gonna remove this IP 30.0.0 .1 255.255.255.0.0. Now we have to give that IP address of 192.168, but before we give that IP address, it's actually not 192. Before we give that IP address, we need to run the command do show CDP neighbors. We want to see the interface on the other side. Do show CDP neighbors. We want to see on multi-layer switch 2. So the interface is actually 02. So if I go to 02, that is the IP address that have .13, in which we need to give this IP address .14. So we will add IP at 50.50.50.14 255.255.255.252. Okay, and say no shutdown. Now let's move on to the other interface as well and find out. I'm just gonna scroll back up to find the other interface as well. This is the other interface that we need to remove. However, this interface is connected to that switch over there, so we need to find out on multi-layer 1. We need to find out the neighbor interface of multi-layer 1 and see on fast 02 of this device here, what is the IP address that is configured. On fast 02, what is the IP address that is configured here? I will have to come here and run the command do show IP interface brief. So on this interface we're using .5, so we're expecting to use .6 on that interface. Cut the story short, we actually have 50.50.50.5 on this fastnet 02 on that switch, on that multi-layer switch, and then we have actually, because this network ID is 50.50.50.4, which means that the first usable IP address on that network ID is actually 50.50.5, which is assigned on this interface. And on fast A0/0 we have removed .14 because initially we have assigned 50.50.50.50.14, which we were actually supposed to assign 50.50.50.6, which is the IP address or the last usable IP address on this network ID. So this is what we're gonna check now. Do show IP interface brief. This is telling me that the fastnet 0 is not assigned with any IP address. However, FA1/0 have this IP address. FA1/0 is this interface. It have .14 because this interface here is assigned with .13. Okay, now let's select fast interface or fast Ethernet interface 0/0. So let's come in here and type interface FA 0/0 IP at 50.50.50.6 255.255.252 no shut. Okay, do right. So we have successfully assigned the IP addresses accordingly. So all we have to do now, we need to type the command router OSPF 10, specify the network ID, which is the router ID. Sorry, maybe let's give it 2.2. or maybe let's just say 1.1.1.2. The network that we're willing to associate with this router, it's actually 50.50.50.4 with the subnet mask, sorry, with the wildcard mask of 0.0.0.3 area 0. Okay, let's check what is missing. It's actually 0 here. And then let's go to other network ID that we actually have to include in here. The network ID that we're willing to include is actually 50.50.50.12 50.50.50.12/30. This is the network ID. Okay, let me just do this again one more time. Let's do it again one more time in here. Okay. So when I come here and then I have to specify the network ID. As you can see, the adjacencies have been formed on that network ID of 3.3.3.3.3. In this case, this is the network ID that is on this router here, which is a multi-layer switch. So let's do the same thing on here. Let's change this into 12 and let's wait a bit and see if there is adjacency forming between these two devices. So let's give it a bit some time and see if there is any adjacency that will form between the two. If there is none that is forming, so we actually need to go back to oh, there we are. There it is forming. We were gonna go back to this device here and double check if the network ID was also associated with the OSPF instance 10. Okay, so yep, these two network ID, they belong to the same area, which is the backbone area 0. So these two, they are OSPF neighbors. Now these two devices, they are OSPF neighbors. So let's go to this one also. To advertise, let's find out what is the interface on this one. It's FA 1/0. Let's find out what is the IP address that we used actually in here on this interface. So enable config terminal do show IP interface brief. Okay, we have this one which is .8. I'm talking about the network ID, don't be confused. This is actually the network ID that we need to include on that OSPF area 0. OSPF 10 in a backbone, so we need to include this network ID. In that case, I will have to say router OSPF 10, and then all I need to do is specifying 50.50.50.8 with 0.0.0.3 area 0. Okay, now let's wait and see if there will be adjacency forming. If there is none that is forming, there is no neighborhood forming between the two devices, that will simply mean that we need to advertise the network ID on the other router as well, so that these two devices, they will form a neighborship. Okay, this is actually taking long, so let's go back there and find out if this was included on a OSPF. Let's come here, let's go back to the other device, which is this one, and see if the adjacency formed. As you can see, the adjacency is formed using this network ID. So actually these devices, they are now neighbors. So if I run the command do show IP OSPF neighbor, I'll be able to see that core layer router 1 as our neighbor. Config terminal, config do show IP OSPF neighbor. Okay, do show IP OS. Okay, I missed something here. This is open path first. Okay, this is open shortest path first neighbor. Okay, what do you see now? We're looking at this. This is 1.1.1.2. This is the router ID that is actually configured on that router here. Okay, so these two devices, they form neighborship. So let's run the same command here, do show IP OSPF neighbor. Okay, as you can see, this is the designated router. So these have the highest this is this have the highest router ID. Okay, so because we didn't configure any priority on both of these devices, so let's check something also. This means that on this router now we have to configure this configuration, router OSPF 10, give it the new ID so that this router won't have. Let's run the command do show IP OSPF, so that we will be able to see that this is actually the router ID. Now if I can go back to this interface, or if I can go to this interface, to this router, sorry, so and run the same command do show IP OSPF neighbors, you'll be able to see that this is actually the router ID of the neighbor. Okay, now let's see on here, exit, do show IP route. This is gonna show us the routing table. This shows exactly the directly connected interfaces and also the advertised network. And as you can see, we have those connected links, these ones, These are the directly connected links, and then we have this symbol 0. This tells us about this network ID, and this tells us about the administrative distance, and then this tells us about the cost. And remember, when we're trying to find the path that can be used to reach towards a certain destination, we actually need to check based upon the highest prefix match, or as you can see, we have that 30, those /30, and then we have those /24s. So we use the highest prefix match method. If we still don't find that working for us, we go to the administrative distance, and then if we find that the administrative distance is actually higher, remember the path that is preferred is the one that have the smallest administrative distance, and then we go to the cost. Okay, so let's come in here, and then let's go to this router over here. We didn't touch upon this ISP2. Let's see what are the IP addresses that are running in there. Config terminal do show IP interface brief. As you can see, we have only 2 IP addresses. Exactly, we are expecting to have 2 IP addresses for these directly connected interfaces, and on our router OSPF, we are actually willing to advertise these 2 networks and associate them as part of the backbone, because let me just do this. This is actually something that we can call it a backbone, you know. I'm just gonna put some kind of a big cycle here, and then I want to indicate that this is actually the backbone. Okay, let me see if I can stretch this furthermore. Okay, let me just leave it here for now, but I want to actually emphasize that for now we are dealing with only one area. This is area 0, and then let me just do this area 0 backbone. Okay, all right, so let's go to that router again and see if we have any do show IP OSPF neighbor. We have no neighbor, and then which means we don't have any router OSPF instance that is running. Let's just create a new one, OSPF 10. Let's give it an router ID. This is the common way of creating or configuring the dynamic routing protocol, specifically this OSPF, because we are currently on this topic of routing using the OSPF. So all you need to configure usually, it's actually the router ID, and then specify the network that you're willing to connect to, and then also it is important to enable the OSPF and the process ID. Okay, so let's run this router ID, and then let's say maybe this is actually 2.2. Or maybe let's just say 2.1.1.1. Okay, now the network IDs that we're willing to mention here is 40.40, which is this one. It's 40.40.40.0. We all know that the wildcard mask of this is actually 3.80, and then we're gonna include the other one as well, which is 20.20. So 20.20.20. Let's wait a bit and see if there will be any adjacency forming between two devices. We're expecting to see from this router towards that router, and also from this router towards this router. If there is none forming, and then we will have to go to each and every router here on the other side, and then we will have to include those networks. Okay, let's do that right now. Let's find out if there is any do show IP OSPF neighbors. Okay, now there are only two neighbors, but we have how many neighbors? We have this neighbor, and then we have this neighbor, and this is our third neighbor. So we don't have this network ID, so which is why we need to include it. Remember, we have to come in here and then type in the command. This is good for troubleshooting purposes. So let's say router. We are already on the router, so we only need to type the command 40. No, it's not 40. This is actually, let's find out. This is okay. Yes, it's 40. So it's 40.40.40.0. So it's 40.40.40.0.0.0.0.0.3 area 0. So we expect to see the neighbor adjacency forming in here. Let's see what's gonna happen. Let's give it some time. Okay, let's give it some time. Or maybe while we're waiting, let's just move on to the other interface as well. Let's move to this interface over here, which have 20.20.20.0. Now if we come here, let's run the command network 20.20.20.0 0.0.0.0.3 area 0. This is good for troubleshooting purposes again. If there is no adjacency still forming, the other thing that we also need to check, we will have to check these interfaces on these routers to find out if they actually have the corresponding IP addresses according to the network ID that is used on those interfaces. This is actually taking longer than expected. Oh, here we are, which means they do actually have corresponding IP addresses that belongs to the network ID that is used between the interfaces. So basically, this is the new neighbor of this router, which is that one, which is this one. And then if we come to this router, we expect to see the same thing. Again, as you can see, there is no neighbor forming between this router and the ISP2. So all we have to do now, we have to double check the interfaces by typing the command do show IP interface brief and see which interface have .40. As we can see, we have no interface that have .40 on its network. Why doesn't we have? Let's double check why. Because if you can try to see, we have all of these interfaces, they're up, and then none of them they're using .40. But let's find out why. So we have this serial 3/0. Let's go to serial 3/0 and find out what is in there. It's actually 30.30.30.2. 30.30.30.30.2. Okay, now let's go to that router as well and find out by typing the command do show IP interface brief. So as you can see, this device also have 30.30.30, which means that what we really meant to do here, this 30 is for that network and this 4 is actually for here. All right, so we need to actually go back in there and then advertise .30 instead of .40. So when we do that, and then there will be adjacency forming between these two routers, which is core 1 and then ISP2. So let's do that right now. All I have to do is type in the command no IP or no network 40.40.40.0 0.0.0.3 area 0. Okay, now I can populate, or I can include that 30. Let me just do this. Now I am expecting to see, let's see. Okay, the adjacency won't form now because we still have to go to core 1 and then we have to update the same configurations. So I have to say, let me start by, oh, there we are, we have the adjacency forming now. Okay, which means actually this network ID was associated with part of that router instance. So let's just remove this one, also this one, or maybe let's just leave it. So let's come here and double check. As you can see, there is an adjacency forming. Now if I type in the command do show IP OSPF neighbors, I will be able to see there are two neighbors of this router, that neighbor and that neighbor. Okay, so okay, I hope this video is actually so informative. This is just the beginning about the OSPF, so there is a lot that we still have to talk about. Again, we'll dive deeper into the links, the advertisement, and then we will move on to multi areas where we will actually have routers from different areas, and then we will have the area border routers, and then we will also have autonomous system boundary routers taking place on that OSPF topic. Okay, so if I can try now to ping each and every device on the network, we will be able to see. I'm just gonna simulate this so that everyone will be able to see the packet actually leaving from the source and for being forwarded directly to the destination. We will also see the switch flooding the packet to each and every devices except from the device where it's received the packet from, okay, or the frame from. So let's do that now. First thing I will do, I'll just double check the IP address on this interface because I'm just gonna use this to demonstrate. So we have 1.3, and on my other side, let's see on the device, maybe somewhere in let's find out this device over here. Okay, maybe this device over here is using 3.6, the other one is using 1.3, and then this using 3.6. This tells me that this belongs to VLAN 30 because on VLAN 30 we use .3. So now I'm trying to ping from other VLAN to another VLAN. I'll try to ping from this PC. Okay, I'm just gonna simulate this so that we'll be able to see the packet leaving from source to the destination. I'm just gonna place it there, and then I'm trying to ping that computer again. Let's watch and see what actually going on here. As you can see, there is the frame, and then it's being flooded to each and every devices except from this one where it's received it from. Okay, and then this switch is a multi-layer switch. It's also did flood the packet to each and every interface that is directly connected to it. Now let's pay attention on this one. Let's not lose it. As you can see, this switch actually forwarded the traffic again to this multi-layer. Now let's see again, this packet is being flooded towards the correct VLAN, and then this device is responding to the switch and say I have that MAC address, and then it's gonna flood it back. It's gonna send it back to that multi-layer switch 2, and then we will finally see that the IP address, the ICMP echo reply will reach that PC. Okay, let's give it some time, and then we will be able to see that in here. As we can see, the status still saying in progress. Let's wait a bit and see all of the movement. Okay, now let's focus on that ICMP. Okay, it's actually taking time than expected. Let's just put this in real time so that you'll be able to see. I'm just gonna do this and then do this. As you can see, this is actually successful. All right, the packet was able to be forwarded towards the destination. All right, so if I come here and then run the command trace set 192.168, let's see, 192.168 168.3 Okay, let's do this .3. Okay, sorry about that. Let's go back to press .3.1. As you can see, this is just one hop away. We didn't actually use none of these routers to forward the packet, so all of these packet forwarding was actually happening on the between multi-layer switch. It didn't actually go to that routers here. So because this is just an internal internal routing and switching. So let's go to the same let's go to the same PC, and then let's try to do a tracer toward the interface that is located in there. In this case is 30.30, maybe .2. Let's try to push it. Let's see how many hops to get there on ISP2. So it's 30.30.30.2. So let's see how many hops to get there. As you can see, it's only just 2 hops away, right? So it went to the default gateway, and then it went to this next hop, right? So from here it went to that VLAN ID of the interface VLAN, and then from there it just went straight to that 30.30.2. Okay, Now what if we want to get to this interface over here? This is actually okay, let me just simulate this. In this case, I'm just gonna grab this and then I'll just okay, this is actually taking longer. Let's just wait for it. Okay, now I want to actually delete all of this and then start afresh the new one. I want to place it here and then I want to try to send it across towards that router over there. Let's see what's gonna happen. It's gonna go via the multi-layer switch. In this case, it's send it to 2, and then from multi-layer switch 2, it's sending straight to that router, and then this router will have to return it back. As you can see, it returned it back, and then now it's gonna go back to multi-layer switch 2. Okay, from the multi-layer switch 2, it's gonna go back to PC2. Okay, as you can see, now it is successfully. This PC can ping this router over here. Now what if we want to ping this router over here? Let's play another one, or maybe let's remove this so it won't confuse us. So we're trying to ping that router over here. Let's see which path that it's gonna be taken. As you can see, because now the switch already know the MAC addresses of all of the devices on the interface, it knows exactly where to send the packet. It doesn't need to flood it again towards each and every collision domain. So the switch sent this multi-layer switch sent the packet toward the router, and then from that router it went straight to that router, and then it's coming back to this multi-layer switch now, and then from multi-layer switch it's gonna go back to that switch over there on the left hand side, VLAN 10, and then from VLAN 10 it will be sent towards that PC, and then the status here will tell us that this is successfully the ICMP echo reply successfully. Okay, what if we're willing to actually ping again? We're willing to ping these servers, this DHCP server or DNS from here. That switch will have to flood the packet because it doesn't know exactly the MAC address. Okay, let's do this. Let's just play so that everyone will be able to see. Okay, I'm just gonna push this down. Okay, this is going to multi-layer switch 2. From multi-layer switch 2 it will have to be flooded to each and every one. Everyone will have to respond and say that no, actually I don't have that MAC address. Our attention is here. From here it's also flooded, and then this one replied and say I am the DHCP, I have that MAC address. Now it's returning the information again. Okay, there we are. Now it's gonna go back in there. Okay, let's see what's gonna happen with the ICMP echo reply. As you can see, we can successfully ping that DHCP. Now let's try to ping again the DNS server from the same PC. Okay, I'm gonna do that. There won't be any flooding across this path now because all of these switches, they already know where to go. They already learned the MAC address of each and every interface in here. Let's do that now to find out. Packet is leaving from PC2 to layer 2 switch, went straight to distribution switch, multi-layer switch, and then went straight to the layer 2 switch on VLAN 60. VLAN 6 switch doesn't have to flood the packet. You know exactly where to go now because the MAC address table will be showing us exactly the MAC addresses corresponding to each and every devices on those collision domain interface. Okay, now it's gonna send back the ICMP echo reply exactly to that PC, which is PC 6. Now we have the successful ICMP echo reply. So we didn't actually configure the priority here. There's a lot that we didn't actually configure in here. So what we can actually do now is to go through each and every router here and show exactly what is the routing table in here. So do show IP OSPF, let's run the command do show IP route. This is the command that is used. As you can see, we currently doesn't have any gateway of the last resort because we didn't use any default routes in here. The moment that we use the default routes, however, we will be utilizing that default route in many upcoming videos when we actually use the EVNG and use the real nested network, where we're actually gonna be seeing the internet actually being utilized towards the connected devices. We'll be able to go through each and every web links, and then we'll be able to ping the internet to run some tests. Okay, so these are actually directly connected links, and then these are all our OSPF routes that we have on our routing table. This tells us exactly if we need to go towards the certain network ID, which hop maybe we need to take, all of those, which hop that the packet will have to be routed towards. All of those we already tried to mention something called the control plane. Let's meet on the next upcoming video where we'll actually try to touch upon multi areas, and then we'll try to see how to actually communicate to areas using the backbone. Okay, I hope this video was so informative to you. Okay, goodbye.